Assalamualaikum and hi everyone. We are still in the topic of hypothesis testing. Previously, we have learned hypothesis testing for one sample test and also for two sample tests. In one sample test is basically we have one group of population, and then from that population we take one group of sample. The objective of testing is basically to know is there any differences in mean sample when we compare to the mean population. Whereas for two sample tests, we have two group of populations, okay? And from these two population, let's say group 1 and group 2, okay? Each of the population group will take sample accordingly, sample from group 1 and also sample from group 2. The objective of testing is basically to know is there any differences of population mean between the two groups based on the sample information. So that is the hypothesis for one sample and two sample, where we can use the t-test or the z-test for hypothesis testing. Okay, now how about if we have three sample or three groups? For example, we have data for recovery period for COVID-19 cases. The first group is teenager, the second group is adults, and the third group is senior citizen. So we have basically three groups: teenager, adult, and senior citizen. Okay, that data is basically referred to the recovery period of COVID-19 patient. From this data, we want to know whether is there a difference in mean recovery period among these three groups: group of teenager, group of adult, and group of senior citizen. So in this situation, what kind of analysis is appropriate? The answer is that for these three groups or more groups, we have to use one-way analysis of variant, or we call it one-way ANOVA, to test the mean differences among several populations. So in this video, I have decided my presentation to three parts. First part is on the theoretical aspect of one-way ANOVA. Second part is the hypothesis procedure using manual approach calculation. And the final part, the third one, is the hypothesis procedures using Microsoft Excel. So let's proceed to my presentation. Okay, to understand the theoretical aspect of one-way analysis of variance and how to calculate the variance, let's use the following example. Let's say we have data on recovery period for COVID-19 cases from three groups of patients, which is the first group is teenager, the second group is adult, and the third group is senior citizen. And from this data, we want to know whether there is a significant difference in recovery period according to type of patient, which is referring to group of adult, group of teenager, and also group of senior citizen. And before we proceed, we should hold these three basic assumptions. The first one is population are normally distributed. The second one is that population have equal variances. And the last one is sample are randomly and independently drawn. Okay, so these are the three basic assumptions. Next, these are the data for COVID-19 recovery days. The first group is teenager. Okay, let's say we take 5 samples from the first group. 7, 5, 6, 4, 3 is the data for the sample taken, 5 sample. This is the second data from 5 sample from adults. And last one is data from senior citizen. all we have 5, 5, and 5 data. Before we calculate the variance for amongst uh, groups and also variance within the groups, first we have to calculate the mean for each of the groups. Okay, so this is the mean for teenagers, mean for adults, and mean for senior. Next, we have to calculate the overall mean for all the data. From these three set of data, we calculate the mean. We call it overall mean 16.87 here. Next, to understand, we can use this graphics to see where the data are located, and also where are the means located. Okay, so the yellow one is the data for teenager groups, the blue one is the data for adults groups, and the green one is the data for senior groups. Okay, let's say here this is the data, the first data for teenager 7. This is 7 located here. The second is 5. This is the second data located. The third data 6. Okay, this is the third data located for teenager, and the same goes for every data. Okay, we have calculated the mean, so now we can see where is the mean located for the first data set. Okay, so basically these are the mean for teenager. X bar equal to 5. This is the mean, and then mean for the second groups. Okay, 16.4. This is where the data is located, mean. And the third group, the mean here is located here, 29.2. Okay, 29.2. So this is the mean for each of the group. Then next is that we can locate the mean for overall. Okay, here 16.87. This is the mean for the overall. Okay, the reason why we draw this basically to enhance our understanding, to see this what we call the distance between the data when we compare with the overall mean. Okay, so in ANOVA we have, as I said before, we have to calculate the variances. So in total, the variance basically we can divide it into two parts. The first one is that the variation due to this group. So because of that, we have to calculate, we have to see the variation among the group. SSA here is means sum of squared. A is for the among, meaning that we want to see variation among the group. The second part for the variation is that variation within a groups, which is variation due to random error. SSW, W stand for within, meaning that sum of squared within, or which is referring to variation within a groups. Okay, so now we see the first part of variation first. Variation due to the factors, meaning that variation exists among groups. So this is the formula, okay, to calculate variation amongst the groups. We have three groups here. First group yellow, second group blue, the third group green. So we want to see variation among the group. In order to see variation among the group, we have to compare. Here is the basic concept, comparing the mean for that particular group to the overall mean. Okay, mean for the particular group compare with the overall mean, and then we square the value. Let's see this. This is in graphic, the first one. Okay, this is the mean for first group. We compare with the overall mean. The green, sorry, the red one is the overall mean. Okay, we see the distance. The second distance for when we compare mean for adult and we compare with the overall mean. The last one comparing the mean for senior and with the overall mean here. Okay, so by graphic we can see like that. So by calculation, this is the things. Okay, SSA. This n is basically the number of sample. Okay, just put all the value in the formula and then finally we got the variation for the SSA is equal to 1465.73. Next, we have to calculate the mean squared. Okay, mean squared among groups. The formula is simple. The SSA divided by this C minus 1 is the degree of freedom basically. C is the number of group. We have three group: one teenager, second adult, and senior. So 3 minus 1 is basically 2. So this is how we calculate the MSA, mean of squared among, and the final result is 733. So these are the calculation for variation among the groups. Okay. After we calculate the variation among the groups, now the second part of variation is that variation within a group, meaning that variation exists in a particular group. Variation in first group, variation in the second group, variation in the third group. So that's how basic understanding. This is the formula. Okay, sum of squared within, meaning that variation within a group. So here basically we have to see the difference or the distance between each of the data in first group compared with the mean for that particular group. Okay, and once we finish the first group and then we go to the second group, again we see the difference between the first data or each of the data we compared with the mean for that particular groups. Okay, for example like this, the first group. Okay, the first data here we compare with the mean for this group. So basically every data here, every value we compare with the mean. After we finish this and then we move to the second group, every data here we compare with the mean of this data set. Okay, every data. Once we finish calculate the variance here, the distance here, then we move to the third data. Every data here we compare with the mean for this particular groups. Okay, so this is the graphical understanding for this SSW. Okay, so this is the calculation. Okay, mean SSW, the first data for example is 7. Okay, 7 minus average mean here. Okay, 7 minus average and squared plus the second data 5 minus the average. So we will continue this until the last one. For example, the last one 30 for the senior group. The last data is 30 minus the average for this group 29.2 and then we squared. Okay, so this is the basic calculation for SSW or sum of squared within a group. The answer is 72. Next, as usual, we have to calculate the mean of squared within the groups. Okay, the formula is very simple. SSW divided by n minus c. N minus c is degree of freedom. N is the total number of sample. 5, 5, 5 meaning that we have 15. The total number of sample here we have 15. So n is 15 minus 3. C is basically the number of group. We have 3 group: one teenager, adult, and senior. 3 groups, so 15 minus 3. Okay, so the MSW is the final answer is 6. From here, basically in manual approach, we have normally to make our understanding clear. We have to fill up this table, okay? Variation among group, variation within the groups. Okay, we have calculated just now SSA, SSW based on the sum of squared calculation, and then we calculate the MSA. Okay, SSA divided by the degree of freedom. So these are the basic information that we have to provide and fill up the table. Before, the last one is that we want to calculate the F statistic, the value of F, because in this ANOVA we will apply the F distribution. Okay, F distribution, not the Z distribution, not the T distribution, but the F distribution. So to calculate the F statistic, this is the formula MSA divided by MSW. Okay, so basically we have all this information. We have calculated before SSA, SSW, MSA, and MSW. We have calculated before. So we just see this table. Okay, this is that the value that we get from the previous calculation. So the F statistic is basically 1 to 2.1. For how we get, basically here 73 divided by the 6 based on the above formula. Now let's see the hypothesis testing process. As usual, we have to develop the null hypothesis. So in null hypothesis, we will assume that every all of the mean from coming from this three set of population are equal. Mean for teenager equal to mean for adult equal to mean for senior citizen. All the means from these three groups are equal. So this is the null hypothesis. The alternative hypothesis means are not all equal. At least one is not equal. Okay. So to do the testing, let's say the significant level is 0.05. Degree of freedom, as we have calculated before, the degree of freedom for amongst group 2, 3 minus 1. The degree of freedom for within group 15 minus 3 is 12. Okay. Next is that we have to refer to the this is the F distribution. Okay, this is how the curve looks like. We have to get the critical value for F. Okay, critical value for F. So let's see how to get the critical value. We will use the F distribution table. Let's see and look. So this is the F distribution. How to read the critical value for F? We have to part here. We call it numerator degree of freedom. This one referring to the degree of freedom for SSA. Okay, so degree of freedom for SSA is that C minus 1. In our example, we have three group minus 1, 2. So we look on this 2, this column. And then this is the degree of freedom for SSW, which is N minus C, and the total number of sample 15 minus group 3, so 12. So these are the row that we have to refer later on. Okay, this is the column that we have to refer. So okay, here, so these are 3.89 is the critical value for F in our example. So after we get the critical value for F from the F distribution table, we can put it this value here, F equal to 3.89. Where should this value located? Basically on our right, because on our left here, we start with 0. So when we move to the right, the value will be bigger and bigger. Okay, so 3.89 should be on our right. So next is that we have to put the value of f statistic in this graph. So we have calculated the f statistic, which is 122.14. So this value should be located far on our right side. Okay, so 3.89 will be on the left, and 122.14, the f statistic should be far on the right side. And since this value, the f statistic fall in the rejection region, so the conclusion is that we have to reject the null hypothesis, where the conclusion is that there is evidence that at least one mean of the population differ from the rest. Okay, at least one. So that is the manual calculations, okay, for the hypothesis testing. And we have another option to run the analysis, where we can use Microsoft Excel, where the step is faster and easier. Let's see how we do it, the analysis using Microsoft Excel. So in Excel, we have to key in the data for this group, teenager, adult, and senior. Once we key in the data, now we are ready to go for the analysis. We click for the data here, and then we go to data analysis steps. So in this dialog box, we pick ANOVA single factors. We click here and then OK. Input range. Okay, we should highlight this area or the data set, the three from the three groups. Okay, groups by column. Yes, this is by column. Label in first row, so we don't tick this one because when we highlight the input, we don't highlight the label, so make it you don't tick. Okay, alpha just 0.05, and then we go for output range where we want to see the output. Okay, let's see, we put it here. Then we click OK. So this is the result. Okay, very fast. This is the information, the summary. Group number one have all the five data, 555. Then this is the average for first group, average for second group, average for the third groups. So here the ANOVA tables. Okay, this is the SSA. Okay, amongst group, between group, here is basically this is the SSA value between groups. Okay, this is the SSW within SSW 72, the same as what we calculate. This is degree of freedom for SSA 2, degree of freedom for SSW 12, and this one is MSA, mean of squared amongst group. This is MSW within groups, MSW 6. Okay, this is the F value that we calculate, the F statistics. Okay, and this is the F from the table, F critical value. This one is F for statistic that we calculate. Okay, so how to make a decision whether we want to reject or do not reject the null hypothesis. We put here F critical value here, okay, in the F distribution, and then F statistic 1 to 2 far away here, far on our right. Okay, so since this F statistic fall in the rejection area, then the decision that we made that we reject the null hypothesis, and there is sufficient evidence to believe that the mean of the population are not equal, at least one. Okay, so that is how Excel work for us very fast. Okay, beside using critical value F and F statistic to make a decision whether we want to reject the hypothesis or not reject the hypothesis, we also can use the p-value and the significance level to decide whether we want to reject or not reject the hypothesis. So comparing p-value is and alpha is the easiest way if we don't have the uh, uh, F table. Okay, so for example, first this is the p-value. Okay, I put in blue color here. The p-value, p-value here is very small. Okay, the decimal value is about 8. Okay, for example, here is the p-value is 0.00000000105, which is too small. Or we can, for example, we can if we do want this figures, for example, we can format, go to numbers up to 2 decimal places. Okay, so basically here p-value is 0.00, meaning that very small. So then we compare with alpha. We know that alpha is 0.05. Okay, so since the p-value 0.00 is smaller than alpha, then we reject the null hypothesis. So that's all for one-way analysis of variant or one-way ANOVA hypothesis testing. Thank you for watching. See you in the next video.